Hi, I'm Mike Bush.
I'm Paul New.
And I'm Colleen Sterling. Welcome to Ask the AMPs from AOPA.
On Ask the A&Ps, we take your toughest maintenance questions and do our best to answer them. So if you have a question, um, contact us at podcasts@aopa.org. That's podcasts@aopa.org.
And if you like the show, be sure to follow or subscribe so you never miss an episode.
And if you'd like to get on our email list for our monthly newsletter and maintenance stories, we're just sending out a really good maintenance story today, I think. Um, the easiest way to do that is to pick up your mobile phone and text the word savvy, SAVVY, to 33777. And a little email bot will ask you for your email address and put you on the list. That's text savvy, SAVVY, to 33777 to put yourself on the list.
All right, so I have a thing I did.
Uh-oh.
It's
You
always
did
something I
something.
did.
Here comes an admission.
No. Well, sort of. It's one of those. You do you think about, am I going to look at something? Because if I look, I can't not unsee it.
Hmm.
But my engine has a bit over 2,200 hours on it. Way back when there were some cylinders pulled, not because anything wrong with the cylinders, but because some exhaust studs had eroded and broken off. So they were just pulled off to replace the studs, put right back on. The engine's using a pretty good amount of oil, and we've talked before on the show about I'm losing a little bit of airspeed. So my plane's in for annual, and I'm doing an autopilot upgrade. And I made the decision that I wanted to see the lifters because I thought, well, maybe I've got some lifter wear. It's a 20-year-old engine. So I pulled all the lifters out of the left side, and lo and behold, they were all perfect, absolutely beautiful. All the cam lobes are absolutely beautiful. One exhaust cam lobe on cylinder number 2 had one little bitty pit in it, but not at the apex. It was on the upward side, and I was absolutely thrilled. I did replace one lifter because it had a few little pits around, but nothing serious. And so, it's kind of a weird feeling, but it's like, oh, I have a brand new engine now because I know what all the important bottom end stuff I know about and not worried about the cylinders. The compressions are mostly okay. The borescope looks good, but that was, one of those things it's kind of, you hold your breath when you take
I,
those
I,
out.
I got to tell you, Paul, what were you thinking when
I
you
know.
decided to pull those lifters? I mean,
Well-
were you doing a pre-buy on your own airplane?
Well,
Why
so
would you do something like that?
well, it hit me. It didn't hit me, but all the things I talk about and we talk about, the camshaft was my concern. At 2,200 hours, if I had some lifters that were bad, I wanted to get those out. I wanted to find out before I ruined the cam. So that was really my objective. It wasn't the lifters, it was the cam. Because if the lifters were bad, I was going to get those replaced and hopefully save the cam and save pulling the engine because
And you don't think that if you had a bad lifter, you would see some metal in the filter? Do you really have to do that invasive a way of finding out?
well, I have had a couple of engines over the years where we have discovered lifters that were pummeled and no obvious evidence in the oil filters because it happened over such a long period of time.
Uh-huh.
So this was it was 6 man hours to pull them and put them right back in, and just a minimally invasive kind of thing to do. And just gave me a huge amount of confidence that I was not somehow failing a camshaft.
Well, now you should buy a lottery ticket, Paul.
I like it.
But anyway, the funny thing, the reason I'm bringing it up is the change in attitude about the engine. It's, some people put on a new engine, they're all excited. I've got this engine. And what do they usually say? It's running strong. And I have no clue what that means. or what they think it means, but yeah, my engine is running strong. And so now I haven't run the engine yet, but I just know that when I get it back out, it's going to run strong. That's my story.
They always run strong right up until they don't.
Right up until they don't.
Our first question is from Chris, who is tired of his dirty belly. Go ahead, Chris.
Well, greetings, guys. Colleen.
Hi.
Well, first of all, thanks for producing such a great podcast. I need some advice. I own a 1968 Piper Comanche, single engine with the Lycoming IO 540 engine. It has about 1,900 hours on the engine. Unfortunately, about 10 years ago, the engine developed a split line oil leak towards the front left of the block. Now, oil consumption is about 1 quart every 2.5 to 3.5 hours. The majority of it being placed on the airplane's, belly's left side. Now, some mechanics say there's nothing to be done until overhaul time, while others have tried covering the leak with fuel tank sealant, but it really didn't work. They even tried an air oil separator, and that didn't work either. I've read about a trick that requires pulling a slight vacuum on the engine from the filler tube while having the breather lines plugged, and then spreading like a line of Loctite 290, the self-wicking type, around the leaking area. Now, my current mechanic doesn't believe the oil leak to be really worth his time, but my OCD keeps this issue in my mind every single flight. Now, I know what you're going to say. I know oil is cheap, but is there anything I can do to seal this leak, or do I really simply have to continue dealing with it until time comes to overhaul the engine?
I wasn't going to say oil is cheap. I was going to say oil is messy.
Yeah.
Yes,
It's messy. It would bug me.
Well,
I'm
and
with you,
there's
Chris.
no way that you're running a quart out of a leak in the crankcase every
Yeah.
3 hours.
So what
That
else
would
do we
be a quart of oil coming out of a leak there'd be puddles in the cowling, and the belly you would be dripping a silhouette of the airplane on the ramp.
So, Paul, you're saying we got two different problems going
We
on
do.
at the same time.
Yes.
Absolutely. Yeah. You've got something going on with the inside of the engine, and we can talk about that in a minute. You've got a leak from this split in the case halves or whatever. That would be the least of my concern. I mean, unless the engine is getting totally covered in oil. If it's the oil is on the belly, then the leak in the crankcase is something I would ignore for the moment and deal with the other one first.
But that doesn't, Lycoming actually has an approved procedure, doesn't it, for case?
Seepage at the seal at the
Yeah,
seam.
for putting some kind of epoxy on there or something. Because
Ooh.
I remember seeing a Lycoming with just like tons of this epoxy all over, and I questioned it, and Eric, who's an engine builder, has built a lot of Lycoming engines, said, "Oh yeah, that's an approved procedure."
Well, my Cardinal had RTV all down the seam when I first bought it, and that didn't work at all. So
That won't stick.
Yeah, no, it definitely wasn't RTV. It looked kind of like JB Weld is what it looked
Yeah.
like.
Yeah.
It was gray and hard.
have fun
looking.
taking that thing apart when you
Yeah,
need
it's-
to.
Yeah, that
That'll be
was
somebody
my
else's
reaction.
problem.
Is I said, I would hate to be the engine builder who has to split the case, but
But that's
that's
interesting.
somebody
Mike,
else's problem.
you don't remember if it's a service letter or something like that?
I don't. I actually read about it on the forums.
The thing is, if you put a vacuum on the crankcase and suck some sort of sealant inside, you don't know how far it goes, and I'd be really concerned about that because on the your camshaft is in the top, so you're going to put this on the bottom. There really isn't anything for it to get into, but you still don't know where it goes. That would be my concern.
Into like oil galleys, that would be bad.
Yeah,
right?
oil galleries, maybe up
At
into
the,
the nose
the
case
bearings.
where the bearing is.
Yeah.
But if there's a Lycoming procedure, which I don't know about it, I've not seen that, but I almost never see Lycomings anymore. So
I'm sorry.
almost everything I see is big bore Continentals. No scoffing,
Discrimination.
discrimination.
But my first thought when I read this was, yeah, where else is the oil going? And the question was, at
that's-
1,700 hours, are they original cylinders, Chris, or have they been overhauled once or replaced?
They look like original cylinders, and yes, the except for one of them that was replaced a little bit ago. But
So-
yes, the engine bay is pretty much saturated with oil.
Does it have
Oh.
puddles? Do you clean the engine bay at oil change time and see how much puddling occurs, in the 50 hours between oil changes?
Everything's just coated with a layer of oil. There's some areas that have maybe a little bit more puddling than others, but generally it comes out the seam underneath.
Well, it goes everywhere when it comes out, right? So
Yeah.
there's,
Oh,
there's
yeah.
a
Yeah,
lot
a
of
little oil
culprits.
goes a long way. I think Paul's point is well taken that
Yeah.
that leak is certainly not accounting for all the oil consumption, but it is messy and it's probably worth trying to stop. I wish I had the service letter from Lycoming's number at my fingertips. I don't. I just seem to recall that Lycoming does have some procedure for trying to deal with those things. So it would be worth researching and finding it out and giving it a shot.
But the rest of the oil, you could very easily be burning it. I mean,
Well, it could, or more likely, could be blowing it out the breather if it's on the belly.
Yeah. That's
If
what I'm
it's
thinking.
burning it, it's not going to be on the belly.
he didn't say that. He said it was in the engine compartment.
Well, but he said he has.
I
Chris,
think we
he's
have
cleaning the belly,
two
yeah.
problems here,
Yeah.
Colleen. The stuff in the engine compartment is coming from the
crack.
the leak.
Okay.
Yeah.
The leak is probably fixable. At least it's worth a try.
Mm-hmm.
That's not going to account for all the oil consumption. That's only going to account for a tiny fraction of the oil consumption.
Yeah.
Right.
The rest of the oil consumption is, either the oil's being burned or the oil's being ejected because of blow by.
Okay. Yep.
And with a 1,700-hour engine, the blow by philosophy is probably more
Yeah.
probable.
Mm-hmm.
A ring wash might be worth a try. We've had, so you just never know until you do it whether it's going to work or not. And sometimes it works on some of the cylinders, not on other cylinders. And but it's certainly worth a try to clean gunk out of the ring lands. And
Chris, do you understand the concept of the blow-by is being caused because the cylinder's pressurized and the oil control rings are not sealing, so the oil's getting blown into the crankcase and it's going out the breather tube onto your belly?
That makes sense, and I see what you're saying, that this could be masking a different issue.
yeah, it's not really oil that's going past the rings. It's combustion byproducts that are getting past the rings that are pressurizing the crankcase. The crankcase is full of an oil mist whenever the engine is running, very dense oil mist. And so if there's excessive crankcase pressure, then there's going to be excessive discharge out the breather. And that discharge out the breather is there to allow pressure in the crankcase to get vented overboard. But the air inside the crankcase is heavily laden with oil. And so it carries a bunch of oil with it going out the breather.
And the ring wash procedure cleans up the lands that the oil control ring
Yeah.
sits in?
Yeah,
Sometimes.
Hopefully.
yeah, it either cleans them up or it tells you that they're
Can't be
too
cleaned.
far gone to clean up without
Yeah.
removing the cylinders.
But if
And-
the oil control ring can move, then it can seal better, and so you would prevent that pressurization.
the gunk in the lands prevent the rings from moving freely in the grooves and so screws up their ability to seal. For listeners who aren't familiar with the ring wash, just very briefly, it's a procedure that involves filling the combustion chamber of each cylinder with a solvent mixture, and then with the spark plugs installed, pulling the prop through to force that solvent through the ring pack into the crankcase. We do this at oil change time because we obviously want to drain all that solvent out and service the engine with fresh oil when we're done. And it usually takes a few tries each time you pull the prop through with the solvent in the chamber. It gets a little easier and a little easier to pull through, and you can kind of tell when you've gotten all the gunk out. And sometimes the rings will be so gunked up that you literally can't pull the prop through, no matter how hard you pull on it. And then you know that cylinder is so severely gunked up that the problem won't be able to be resolved without pulling that particular cylinder off. So, but even if you can clear up, half of the cylinders or more than half of the cylinders that way, it's worth doing, and it'll reduce oil consumption considerably.
So
And most of that gunk, we think, is a byproduct of the fact that we're running leaded fuel. So the hope is when we transition to unleaded avgas that gunking up of the rings problem will go away.
So back in the day, when I had a Comanche, it was a 59 model with the 0540, not the IO 540. But as is typical with me in aircraft ownership, it had excessive oil consumption. And this was back before the days we ever even thought about a ring wash. But these Lycoming engines have the little sprayer that sprays oil in the bottom of the piston. What I finally, my compressions were like 78/80. They were just incredible. Well, of course, the rings were all gunked up, and that's why the compressions were so high. But it looked good on paper.
Until they weren't.
Until they weren't. So we pulled the cylinder off, and what had occurred, and this is kind of a strange, but there was a crust on the bottom of the piston that coated over the the 4 oil return holes. Mm-hmm. So not only did the oil scraper ring groove get clogged up, but there's this coking effect like an iron skillet on the bottom of several of the pistons that.
Hey, Paul?
Yeah.
Those are not oil return holes. They're oil supply holes. That's how the piston gets lubricated.
Okay. Oil supply. There are holes in the piston. And they
yes, there are. There are only 4. Oh, my goodness.
There are only 4. And
those are important. Those are important holes.
Those are important holes.
And I've had a cylinder that I didn't know at the time that the oil control ring was getting stuck, and it actually broke.
Yeah.
And when I removed the cylinder started doing weird things like detonating, just doing like uncontrolled CHT excursions. I finally pulled the cylinder, and it all came out and fell on the floor in 9 pieces. So you don't want to let it go that far.
Yeah. Did you have any scratches on the cylinder walls?
This was before the days of Borescope.
Yeah.
And I don't remember. We just replaced the cylinder.
Yeah. Wow.
But that, as I said, the ring wash sort of has a dual function. It sometimes is therapy, and it's sometimes diagnosis. It depends on how it comes out.
Yeah.
But if you can't force liquid past the ring pack, then something is severely wrong, and it's probably worth pulling the cylinder at that point.
So, but Chris, above everything, don't let your mechanic say it's time to overhaul because you have a leak.
Right.
Because we hear that a lot.
I've listened to you guys long enough to know that answer. Absolutely. And,
Excellent.
And a ring wash, that's a great idea that I haven't heard before. So that's definitely something we're going to pursue.
Yeah. If you go to the website, it's resources at savvyaviation.com. There's a ton of stuff there, but one thing you can find there is a link to the write-up of exactly how to do the ring wash procedure.
Fantastic.
Yeah, and we'll see if we can't find that Lycoming instruction for sealing a
for
case
JB welding the seam.
Yeah. So, and if we can, maybe Ian can post it on the show notes.
Let's vacuum some JB Weld into the crack.
I love JB Weld. That stuff works great. Okay, well, Chris, great question.
If that leak can't be JB welded, then it's a bad leak.
It's a bad leak.
All right.
All right. Well, good luck with that, and thanks for calling in.
Thank you very much, guys.
Yeah. Thanks, Chris. Our next question is from Bruce, who's looking for the right balance with his prop. Go ahead, Bruce.
Hi, thank you very much for having me on. I must confess I've listened to every podcast that you've done so far and find them quite enjoyable and sometimes informative.
Sometimes, but that's what we're shooting for.
Well, sometimes they're relevant to my case, and other times,
okay.
other times they're not. But they're always enjoyable.
Good.
So
They're always informative, but they're sometimes irrelevant.
There you go.
yeah.
Okay, I could live with that.
Yeah, I can do that.
So I recently installed a Sensenich ground adjustable propeller, which is a carbon fiber composite unit. If you're familiar with those, they have a really clever pitch setting mechanism with pins that you put in and rotate the propeller until the pin contacts a guide pin, and then tighten it all up. And you're supposed to be good to go. You do that on both blades. So they don't talk about pitches, they talk about pin numbers. And the lower the pin number, the lower the blade angle, and the flatter the pitch, and the higher RPM you get. I've now run it at 2 different pitch settings or pin numbers. And the flatter pitch, of course, gives you a higher RPM at the top end. And it also gives you a little higher static and better climb, as you'd expect. And then as you increase the pitch, but each pin seems to give you about a 100 RPM increase in RPM as you go down, and obviously 100 RPM reduction as you go up. So the question is, how do you come up with what the optimum is for the airplane? And is there some reason or some advantage to having a greater pitch running at a lower RPM for a given power setting? Because I did find that I could look at the different pin numbers and there's an RPM change, but if you take the lower pin number and you increase the RPM, you end up at the same power setting as you would if you had the higher pitch. And can you go too far with that?
Ooh, interesting. So the first thing that comes to my mind is this is for a Lycoming 0320. Do you have specs for that engine, what its maximum and minimum static RPM should be? If it was a Cessna Skyhawk and we were doing a pre-annual run, we would make sure that the ground run RPM was within a given plus or minus. So I think that if you had that would be my call for here's your minimum and maximum, and then where you put it within that is a matter of, do you want to climb fast or cruise fast?
I don't have that for the engine. For this engine, I do have it's redlined at 2700, and I can reach that with a flatter pitch. But if I
put going downhill,
right, if I put the coarser pitch on, then I can reach 2600 RPM with wide open throttle at sea level. But I get the same power readout, percent power, and airspeed and fuel consumption as I would, at a flatter pitch and a higher RPM. But it's running slower, it's quieter.
Yeah, the flatter pitch, obviously you get the maximum performance for takeoff and climb, and the coarser pitch will give you a better performance in cruise. And if you go too coarse, then you won't be able to get you won't be able to reach the power setting you want to cruise at. Like, for example, 75% power. You may not be able to get that.
Is that a problem with the engine? Is it kind of, is it like a car going uphill and too high a gear and the engine starts lugging?
It's kind of like that. But basically your power, do you operate this engine Lena Peak or Richa Peak?
Well, I try and be lean of peak, but it doesn't really like being very far lean of peak.
Okay, well, if we're talking about Richa Peak operation, then the engine power is a function of manifold pressure and RPM. And if the prop pitch is too coarse where you can't get as much RPM as you want, then you can't get as much power as you want.
But it's not harmful to the engine if you can't get there.
It probably reduces your detonation margin a little bit, so you don't want to go too far. But it would also give pretty poor climb performance if you went that course.
Isn't it easier on the engine to operate at a reduced RPM for longevity and wear? I mean, as long as you can sacrifice it for performance.
Well, on a
It's
constant
not
speed,
easy. It's not easier on the engine. It's more efficient. It's
I was thinking about internal wear specifically.
well, wear shouldn't really be a problem in these engines. Most of the wear occurs at startup and stuff. It doesn't occur when the engine is operating.
So it's okay to just zorch around at 2,700 RPM all the time.
I do it a lot.
It's fun, but
It goes-
and
it goes-
uses a lot of fuel.
Well, at like on my airplane at 9,000 feet, if I want to get 75%, that's how I get it.
Right.
Because I'm wide open throttle and I have to add RPM to get that 75%. I do toy around with different RPMs between 2,500 and 27 to see where the propeller is most efficient.
Yeah.
Yeah, high RPMs cause you to have a lot of friction losses.
Right.
Because friction loss varies with RPM and it varies in a nonlinear way. It goes up pretty fast. And it also, the high RPM is a little hard on the engine in the sense that the stresses on things like the rod bearings and the rod bushings and stuff is a function of sort of reciprocation loads where the thing has to take this heavy piston that's moving really fast in one direction and then move it really fast in the other direction.
Mm-hmm.
And high RPM makes that those loads greater, and so puts more load on the bearings and so on. If you have adequate oil pressure, it shouldn't matter, as long as the metal surfaces are separated by hydrodynamic lubrication, it should be okay.
So I tend to run this airplane at lower power settings a lot. We fly in the mountains, and so we're not interested in speed as much as sightseeing, and also not going too fast for the terrain. So I may be operating.
It sounds to me like in that profile that you just described, that you really want a climb prop because you want to be able to get to altitude and stuff like that.
Rebel,
you don't
right?
care that much about how fast
Yeah.
you're going, so that would argue for being at the high RPM end of the adjustment range.
Yeah, well, this is an airplane that's at sea level. It's off the ground at 300 feet and climbing at 1,500. So
awesome.
we've been up in Idaho at 9,000 foot density altitude, and so we use 600 feet.
Tragedy! A whole 600 feet.
It's not that issue. There are a lot of people with Super Cubs that have this type of adjustable propeller, and one of the things they advocate is setting a course pitch and flying cross country to wherever you're going to be, and then landing, and everyone carries their torque wrench with them, so they pull the prop and change the adjustment, and then go flying into the backcountry.
Sounds perfect.
Yeah.
I
But
hope
I'm not-
I hope these pins have safety wire on them or something, or a cotter pin, or
Well, they're not meant to be left in. They're
Oh.
they're
Oh,
just
interesting.
Oh,
they're set
Okay.
in as a guide, and then there's a pin that's epoxied into the end of the propeller blade, and you turn the blade until it contacts the guide pin,
And then,
tighten everything down, and pull the
I
guide
see.
pin out.
oh, okay.
I see.
Interesting.
Okay.
If you haven't, they're pretty clever design
Mhm.
that they've come up with, so that it's actually a 15 or 20-minute job to change the pitch of the propeller.
sounds to me like you need to get a torque wrench like all your buddies.
Well, yeah, well, I've stopped borrowing
has
one
one.
from my
Oh,
mechanic
yeah.
friend and get
Yeah,
my own.
don't-
Yeah.
Yeah, get your own torque wrench. Come
Sounds
on.
like something that has to be in the baggage compartment.
Yeah.
It
Christmas
does.
is coming.
Actually, we do have a torque wrench in the hangar because we built the airplane. So
Yeah, I was going to
there's
say.
a fair supply of relevant.
Put your name
tools.
on it so it doesn't get confused with everybody else's.
But I don't get the idea that you're going to save fuel by running at coarser pitches or lower RPM, because it's all based on the power that you're
Yep.
getting out of the engine, right?
Somewhat. I mean, you can run the mixture in different positions, rich at peak, and get different fuel flow and the same basic power. So when you think about it, when you take off at full rich, you are not at 100% power because you've got all this extra fuel, which is helping cool the engine, not because the fuel is cold, but because it actually reduces the power. So then if you read your charts, it will tell you lean for best power, which means you use less fuel to get more horsepower at that full end. So you can have different percent powers at the same RPM and manifold pressure because you're changing the fuel, you're changing the efficiency of the engine. Stoichiometric kind of stuff. I don't even know if I pronounced that right.
You didn't. But
I didn't. I hate that word. I never pronounce it right. And it's even worse when I see it written. It's like there are way too many letters. It's just too long of a word. I don't know.
Oh, it's stoichiometric is a lot easier to say than pathognomonic. So stop complaining.
are you showing off, you guys? Come
Oh
on.
gosh. I learned a new word today, but I won't tell you what it was. And it was like 5 syllables. So one thing, back to my original thought, because all these other things are right too, but I would suggest Lycoming makes an owner's handbook for all of their engines. I strongly recommend that you go get that from them. I'm sure you can probably find one online in PDF version.
It's the operator's manual, right?
Operator's manual, yes.
Right.
Yeah.
Get the operator's manual and see if it gives you static RPM limits. And wherever you move the prop, I know you're experimental and all that's fun and good, but I think that's a really nice baseline from which to make your adjustments, and try to stay somewhere close to that so that you're operating the engine something close to, not something outrageous like Colleen and her husband Dave do when they go racing their planes at Reno.
Hey, Paul, are you sure that information would be in the Lycoming operator's manual?
I don't think it would. I mean,
Yeah,
but
I'm
that's
afraid
a
it because
good place to go look.
It's typically
It's an airframe thing.
in the aircraft manual, which of course this aircraft doesn't really have one. So
Right.
But if it's an 0320, and I don't know which 0320, 150 horse, there's a lot of Cherokees out there.
go get
lot
I
of
was going to say go get a
172s.
Skylane manual and use
Yeah.
the numbers in there.
Something like that to give you a baseline for, somewhere in this range for static RPM to get your adjustments, just to feel better. I'm that guy, We appreciate you calling.
Thank you very much.
Our next question is from Kirk, who's playing with gas. This sounds dangerous. What's up, Kirk?
Hi guys. I just want to, first of all, I want to thank AOPA and for this AMP, Ask the AMP show. You guys just do a great job of helping GA pilots learn more about their aircraft and how they operate. And we're all going to be better and safer for that. So thank you very much.
Thank you.
Thank you.
So I should predicate this by saying I have been trained by an A&P how to safely service my aircraft's oxygen system. And I always put my cigarette out before I do that.
And you wash your hands.
And that's right, wipe the grease off my
Wipe
hands.
the grease off. No ham sandwich grease on your fingers. Okay.
Right. But seriously, as the aircraft owner who doesn't hold an A&P certificate, am I allowed to refill my own oxygen system? I looked through 14 CFR 43 Appendix A subpart C, which talks about preventative maintenance, and I don't see servicing an oxygen system listed in there, but it's called preventative maintenance. And I'm being funny now, but couldn't you argue that I'm preventing hypoxia?
That's a good one.
That's good. I like
buy
that.
Well, I'll tackle this. There's a couple of relevant things, but let me address your question with a question. Are you allowed to add oil to your engine?
I knew that's where you were going.
Are you allowed to fuel the
Air
aircraft?
tires. Put
That's
tire-
true,
air
and it's not
tires.
listed.
Air-
Okay,
14
none of those
CFR
things are on the
42.
list.
How about putting gas in the tires?
Now,
Yeah.
there's really kind of a fundamental gap in the regs that the things I'm talking about, adding oil and adding fuel and that sort of thing, are things that we refer to as servicing the aircraft as opposed to doing maintenance on the aircraft. And servicing is not a word that's defined anywhere in the regulations. If you look at the definitions in part 1.1, it doesn't talk about servicing. The FAA seems to be silent on that subject. But everybody knows that you're allowed to do it, and it doesn't rise to the level of something that we refer to as maintenance or preventive maintenance. It's a lower level thing than that. So I would view adding oxygen to your oxygen tank to be something, essentially at the same level as adding fuel to your fuel tank or adding oil to your oil sump or tank, whichever you have.
Interesting.
Now, if you did classify it as preventive maintenance, then you have a little cover from something called the Khalil interpretation, which is where about 10 years ago, the FAA regulatory lawyers came out with an interpretation. It was actually written by my buddy Skip Averman, who is our friend at the FAA. I hope he never retires because he's all of his interpretations are so wonderful. Paul and I have had occasion to deal with him. But that basically said, even though the Part 43, Appendix A, Subpart C, says that the only things that are considered to preventive maintenance are these 43 items. And even though there's an advisory circular that says the same thing, but even in stronger language, it ain't true. He said there are lots of things that the FAA would consider preventive maintenance that aren't on the list. And he said that's particularly true for small general aviation airplanes. So that really opened the door that said, those 43 items are not exhaustive, they're exemplary.
Mm-hmm.
And other things that are, comparable to those 43 items would also be considered preventive maintenance by the FAA. And the Khalil decision was triggered specifically by the request from the general manager of Bombardier's Learjet division. And the question he was posing to the FAA was, can a pilot put air in the tires of a particular model Learjet that has very high pressure tires? Because that Learjet has a requirement. Actually, it was, could he check the pressure in the tires.
Check it, not
Because
service it.
there's an airworthiness limitation on that particular model Learjet that said the tire pressure has to be checked every day. And so the question was, do we really need to get a mechanic to do that, or could a pilot do that? And the answer was, if the airplane's being operated as a Part 91 airplane, as opposed to a Part 135 airplane, then a pilot can do it, even though it's not on the list. And that was the FAA deemed that to be a preventive maintenance item. But Skip went much further than that when he wrote the Khalil decision. He didn't just say, yeah, it's okay to check tire pressure. He said there's lots of things that the FAA would consider preventive maintenance, even though it's not on the list. And you should think of that list as being exemplary rather than exhaustive. So that was a very, but as far as adding oxygen, I don't even think that we would need to consider preventive maintenance. I think we would consider servicing, like adding fuel or adding oil. That doesn't have to be on any list.
Great.
So
Well, my
Kirk,
conscience feels much better now when I serve.
So there's two different reasons that it's okay.
so do you actually fill your own bottles, Kirk?
I do.
Or do you fill them yourself in your garage, or do you take them?
No. I work for a corporate flight department,
And they've got oxygen.
I have
Aha.
access to oxygen.
And we're not
Because-
going to say who they are.
Because I wanted to be able to fill my own oxygen system, and so I wanted to get a big e-cylinder to keep in the hangar.
Mm-hmm.
And it turns out, at least in crazy Santa Barbara County, that you have to pay a big fee and get a hazmat certificate and all that
Really?
stuff. Which I thought, I thought oxygen
Wow.
is a hazmat. God forbid what would happen if a little of it
If it
leaked out
escaped.
of
Oh,
I'm,
that's
I'm pretty
funny.
sure it has to do with the 1800 psi that's in the bottle.
well,
Yeah.
it just-
You should see some videos of those bottles when you hack
When you
the-
shoot them.
when you when
It
you
just-
light
it
them
just-
off, so to
it
speak.
just seemed to me that the intention of the hazmat fee was not something like that, but
Yeah. Right. Well, it is
Well-
California.
but it is California. Yeah.
I don't fly with oxygen, although I own an oxygen system now. I guess I should learn how to service it and check it. But at any rate,
But you may do that,
yeah, I can now. But
and you don't have to sign it off with your A&P number.
But my husband uses oxygen a lot and makes me use it too, because he doesn't like seeing me sleep over there in the right seat, which has happened. And so he gets his bottles serviced. And one thing that I didn't realize is that oxygen tanks, the regulation for hydrostatically checking oxygen tanks is a DOT regulation.
Yes.
It has nothing to do with the FAA at all. So the FAA really doesn't even touch this subject unless they're telling you need to use oxygen. But
Yeah, and interestingly, the DOT regulation, which applies to all pressurized gas cylinders, that does not have anything to do with aviation. It's just scuba tanks and welding tanks. It's all covered. But what that DOT regulation says is that if the tank has passed its hydrostatic testing date, you're not allowed to service it.
Mhm.
But you are allowed to use the gas that's in there. Okay, so
Yep.
so if you can't an IA can't say that an aircraft is unairworthy just because its tank is past a hydro date. Although a lot of them do,
Yeah.
but it's not correct.
Mhm.
What an IA should do if the tank is beyond the hydro date is to ask the owner, do you want to have these bottles hydrostatically tested? And if not, he should just put a placard on there saying "Do not fill,"
Right.
Yep.
because
That's
that's what the regulation says, is that
Interesting.
you can't fill a tank that's beyond its hydro date. Not that you can't have a tank or use a tank or.
And if you're going to leave one for a long period of time, have some pure oxygen in it.
Oh, for sure.
Because if they're steel bottles, especially, they can begin to rust on the inside.
Oh,
Yeah.
Oh, interesting.
You don't want them to go empty. Keep some pressure on them.
But so where I was going with this though was you can certainly fill it yourself. You don't have to bring it someplace to have it filled if you want to, break the rules and have something in your hangar, a big bottle. But you do have to respect the hydrostatic testing date, so that
Yep.
doesn't relieve you of that responsibility.
Oh, and also the some cylinders are life limited. The
Right.
one in my airplane is actually, I just had it hydrostatically tested at this last annual, and it's got 3 more years to live.
Mm.
And at 24 years, it turns into a pumpkin.
Just like a parachute. Yeah.
And I had already done that once. That gives you an idea how long I've been in this airplane. So this will be the second time it turns into a pumpkin.
And fill it slow so it doesn't get too hot.
Right.
Yeah, some great videos out there
Yeah.
of what not to do.
Oh,
Yeah, all the ways not to do it. I have
those
not
are all
started
on
making,
TikTok, right?
Probably.
I haven't started making my videos. I can't decide where to start. There's so many. But
Well,
excellent question, Kurt.
great question.
Thanks
Yeah.
for your help. And again, thank
And
you.
fill
for
your
what you guys
bottle.
do.
Go in peace and fill
Yeah.
your bottle.
Yeah, go in peace.
Thank you, Mike, and Paul, and Colleen. I appreciate
Thank-
all of you and what
You're
you
welcome.
do for GA. Thank you so much.
We'll see you.
All
Hey,
right,
would
take
you have,
care.
would you have time for one other quick question?
Oh, sure. Well, yeah.
Always.
Yeah.
Ask
always.
Ian.
Ask
Ian will-
Ian.
Only
Ian
if
will
it's
give us the
actually
hook if
quick.
it's not.
Yes, that's fine.
And
Yes.
if it's not, yeah, I want to respect your time. I just bought an ELSA Sport Cup.
Hmm.
Can I do my own maintenance on that? I've been told that I can. I have signed up for Rainbow Aviation's 2-day course so that I can do the annual condition inspection and sign that off. But can I do my own maintenance? And at the risk of incriminating myself, I just realized the problem.
You know a
Again,
guy.
under the supervision of an AMP. That's right. I know a guy.
You know a guy. I don't know anything about the LSA world, so I'll
Don't
just
you
step
need a
back.
repairman certificate for that, or is that experimental only?
So I think an SLSA you do. An ELSA, I've been told you don't, but I cannot find that in writing.
I'm not sure.
In a reliable source. I can find it in writing on the internet.
I
but
thought
can't-
I thought the rules for ELSAs were the same as for
Experimental?
EABs.
Yeah, I thought so, which means you have to have built
I
it,
would have
or
have to build it, right? Yeah.
I don't think you can go through the course. I think that's an LSA.
So Rainbow Aviation doesn't, they offer a 2-day course for the ELSA so that I can sign off the annual condition inspection.
Hmm.
But
Okay.
they don't even offer, they offer the course for SLSA so that you can do the maintenance, but they don't offer a course for an ELSA to do the maintenance. So
But you
I'll
can
ask
do
them
the
when I
ins-
go take the course.
Yeah, I don't have a lot of experience with those types. I'd have to go back and look at the rules. And these guys are certified guys. They don't know.
Yeah,
That's right.
we don't
Guys.
know anything.
If there isn't a manual they can follow, they don't want to touch it.
That's right.
Well, thanks again. I really appreciate all of you guys and what you do, and AOPA. Thank you.
Our next question is from Robbie, who doesn't believe his gauges. Go ahead, Robbie.
Yeah, so thank you. That's probably pretty accurate. So, first of all, thanks, guys. I binge listened to all of the Ask the ANP podcasts about a month ago before I sent in this question. So,
Oh,
anyway, really
gosh.
appreciate
all
the
at
help.
once.
Well,
Binging.
you know, I every day walking for an hour, I listen to one of them.
Oh, cool.
So I appreciate all the work you guys do. But I have a 1980 Cicada TB10. I got it just a little under 2 years ago in February of 2021. It currently only has the factory single probe engine gauges. I'm actually waiting for parts to arrive. They've arrived and they're waiting for the installation of a GI 275 engine monitor.
Oh,
Yeah, very nice.
you said that to
Yeah.
fend off the lecture, right?
I did. That's exactly right.
Good
I
job.
totally did.
He's not really getting one. He's just,
No, it is true. It is true. Actually, in the shop now.
yeah, excellent.
My problem is that even with significant efforts to manage the temperature on climb out, the most likely unreliable CHT gauge reads close to 500
Ooh.
and rarely drops below 425. And this is an O360, just for those who may not be familiar with the type. There are no other signs of trouble that I can see. It's been this way since I purchased the airplane, but I have to admit that I actually didn't notice it in the beginning because I was not accustomed to flying an airplane with these gauges in it. And so I noticed it in some videos that I took later after I saw it, and I thought, I wonder what this looks high. I should check it. And then I went back and checked some in-cockpit videos I'd taken, and pretty much every time on climb out, it does this. So my mechanic suggests that it's highly improbable that the temps are actually as high as the gauge is reading, and that he suggests that one possible cause is that the cable to the probe was at some point replaced with the wrong type. So I've continued flying and trying to manage temperature as best I can, trying to comfort myself that maybe I just have an erroneous reading. Flying over water to Norway, things like that.
Oh,
With
wow.
Yeah, so-
You're kidding.
wow. And
anyway,
so is that working for you so far? Do you feel good about it? That's
Well,
called green framing.
it's called This Is Why I'm Calling You Guys.
Mhm.
But I also purchased some temperature stickers that I placed in various spots in the engine compartment, even though I recognize these are unlikely to give me any useful information, which has proven to be true. They don't even reach the scale that I've placed them in. So my question is whether there's any way to gain confidence that the CHTs are reasonable while waiting for the installation. Of course, at this point, there's not much waiting left to do. But thinking possibly other indications of trouble, and I did send over the borescope images that I took, although it was my first time ever doing a borescope of cylinders, so I have no idea how good my images are. But that's my question.
Do you smell anything when it goes to 500? You don't smell
Nothing at
oil
all.
burning? Because I've had my CHTs passing 420 and I can smell something in my
No.
cockpit. Now, it might be better sealed on a newer airplane than my.
But it all burned off the first time it happened. You
No.
didn't smell it after that. It's all
I
been
can
cooked
smell.
off.
I can smell when the engine gets hot.
Yeah.
So
Yeah.
that would be an
Definitely.
indication.
I wish I knew how the factory CHT gauge, what kind of probe it uses, because
Yeah.
there are two different kinds of probes that are used for CHT, and
It's not the spark plug probe, if that's what you mean. It's the
no, that's
No.
not really what I was getting at. It was that there are thermistor type probes. There's another more proper word for that, but it's a variable resistor kind of probe.
The
And
bulb.
then there are thermocouple probes, which generate millivolt. And if it's a thermistor type probe, it doesn't really care what kind of wire you use,
Yeah.
but it does care a lot about resistance. If there's any additional resistance, the thing will read high, because the thermistor probe is a probe whose resistance varies with temperature. And so effectively what the gauge is an ohmmeter effectively.
Yeah, makes sense.
But the kinds of probes that most digital engine monitors use are thermocouple probes, which generate millivoltage. And so if there was any resistance, they do care quite a bit about what kind of wire you use, and if there was any resistance in the system, you'd get a lower than correct reading, not a higher than correct reading, because the meter in the cockpit effectively would be a voltmeter or a millivoltmeter
Yeah, makes
rather
sense.
than an ohmmeter. So
Mike, we just had a question for another client that had unexpectedly high CHTs, and Joe Godfrey, who's our lead savvy analysis person, asked about the ground on the engine
Yep.
potentially causing that. Would that be something to check? That he's got a good ground? Or is there even a ground
That's a
on
high
the
resistance
Well,
probe?
return. Yeah.
it depends whether the probe is a grounded type probe or not, whether
Yeah.
the ground is significant.
I'd find it hard to believe that somebody would install the incorrect wires to the probe. I mean,
Well, in all the Cessnas and Pipers, it's the resistive type probe,
Yeah.
and it screws in, and there's one wire attached to it, and the
And
center.
it uses the engine ground as the
Yeah, the engine is the ground return.
yeah.
So if there's a bad ground for the engine, you get basically high resistance. But where the wire screws on to the probe, it's a little bitty post, and very few people have a small enough wrench to hold the backup nut so that when they're tightening the wire, on this little post, the entire post will turn because they put too much torque on it. And this post is in like a ceramic centerpiece. And once that moves, you're going to get all kinds of strange readings from time to time.
Yeah.
We've actually had success in a desperate attempt because you almost can't find these anymore for some of the older airplanes. We'll glob a bunch of RTV or something around that post where the terminal attaches just to stabilize it so it doesn't vibrate. And often we'll get usable CHT readings, at least long enough for someone to go buy a proper engine monitor and put it in.
Yeah, I'm looking at all these pictures as they're flashing by, and the pictures
Yeah.
all look normal. The one picture that I wish I could see is a picture of the probe itself, but
Oh,
Yeah,
yeah.
right.
I don't
That'd be
think
the
that's
one thing
in
to
the-
know.
I don't
But
think
these
that was
are
one of the
these are
pictures.
super sharp pictures. Nice
Yeah,
job.
and
Yeah,
they're
good
very
job.
nice. They're very
Holy
nice
cow.
looking
And everything looks
pictures,
nice and
all
clean.
the valves
So-
are
I watched
healthy and
3 or
stuff.
4 YouTube videos to give myself.
Yeah,
Yeah,
your shot underneath the valve, seeing
valve.
the valve stem, that's a very difficult shot to get.
That's beautiful.
Nice
No,
job.
that's
Yeah.
It's
really
like
nice.
artwork.
Thank you.
Yeah.
But I guess the only suggestion I would make would be to accelerate the schedule on which you're going to install that
Right.
GI
I
275
pick it up.
EIS.
I pick it up next week.
Oh,
Well, you're
exciting.
gonna
Oh,
learn
okay.
everything the first time you fly it next
Yeah.
week.
I'm sure that's true.
Yeah.
And also oil analysis. I've done oil analysis, which is all normal.
Yeah.
But
So,
even even with this 275, the Garmin basically uses everybody else's probes. Everybody uses Alcor probes and all that.
Mhm.
I would suggest, just as a matter of routine, is be sure you have a good ground return on the engine. Have your people check that. Make sure it's in place and in good shape, not oxidized.
Not
I
on the
presume
airframe,
that
on the
I
engine.
presume
Yeah.
that if they when they're doing the installation, that's something they would look at.
I would not presume that
Probably,
at all.
probably not
Sometimes
unless
they-
you
yeah.
specifically call it out.
Right.
th-
Yeah.
w-
I
and-
will
and what we're
write
talking
that
about
down.
is the big nasty looking grounding
Yes.
strap. It's
Right.
that goes from the crankcase to the firewall typically.
Yep.
It
Okay.
grounds the engine to the airframe.
Usually on an American airplane, it'd be a braided strap. I'm
Yeah.
not sure
Yeah.
what they use.
Oh, it's almost certainly a braided strap.
Yep.
And it's
Well, everything
likely.
forward of the firewall is basically
It-
American.
it's typically
Yeah.
it's typically installed correctly when the airplane is built, and then it's
Mhm.
typically
Never
screwed
taken
up
apart.
when if the engine is changed.
Right.
So,
And Robbie, going back to, is it really hitting 500? I wasn't kidding when I said you would smell it, but in addition to
I
that,
thought so.
yeah, we just had another caller that showed us a 20 or 30 degree rise in CHTs, and the oil temperature also went up. If you were
Yeah,
going to 500, you
no
would
indications
see,
like
yeah,
that.
Yeah.
and
Yeah, so
also
you're-
I think that when Lycoming cylinders are running at 500 degrees, I think the paint changes.
It
color,
changes
doesn't
color.
right?
Yeah.
That's
Yeah.
right.
Yeah,
That's true.
that's exactly, my mechanic basically said all these same things, which is
Yeah.
that there
Oh.
should be other
Well,
secondary.
then you probably have a
indications.
pretty smart mechanic.
Yeah, we like your
Yeah.
mechanic.
He's actually very good. I'm very
Yeah.
happy with him.
Can we pronounce his name?
His name is Uvi or something, right?
It's not Gunter or something.
No.
It's actually Bob.
Oh,
What a disappointment. If he was really Dutch, it would have a lot sound in it.
yeah, all,
wouldn't it?
all kinds of extra consonants and things.
The rest of
Oh,
them at the
Bob.
shop are like that, but Bob is a
Right.
disappointment for you.
That's
Well,
awesome.
shout out to Bob.
Hmm.
Good job.
All right. Well, make sure and wear your poopy suit when you're crossing the North Atlantic or the North Sea.
It's
or
a great
wherever.
trip. I highly
It
recommend
sounds
it.
awfully cold. Wow.
No.
Well, great
Well, thank you very
question.
much.
So,
Appreciate
it
it.
sounds like most likely your CHT isn't really 500, and
I think that's
but
probably true.
do put that GI 275
Well, I'm
in.
signing up
It
for
will
your
probably
service as
be
soon as I
eye
have data.
opening.
Yeah. Good. Excellent.
I know when I first put an engine monitor in my airplane, it changed a lot of things about how I operated the engine.
I didn't look
Well,
out the
I'm a
window.
25-year
Yeah.
software
Actual
engineer.
data.
I've been in software engineering for 25 years, so the lack of data is killing me.
Yeah.
Oh, you're
Yep,
gonna geek
like-
out.
Totally
Yeah.
agree.
I'm looking
Yeah.
forward to it.
Yeah, you're going to like it a lot.
All right.
Good. Okay.
Well,
Well, thank you
thank
so
you
much
very
for the
much.
question.
Yep.
All right.
Thanks, Robbie.
Bye-bye.
Okay,
Bye-bye.
take care.
Our next question is from John, who's wondering if there's any truth in advertising. Go ahead, John.
It's a good intro. Look, I'll give you a bit of background. I have a 1995 J model Mooney, and I've flown it for about 2,000 hours. 5 years ago, I had an IO360 A3B6 engine fitted in place of the original engine with the dual mag. And when the first magneto inspection was due, I had one mag replaced with a Shorefly electronic ignition. Overall, I'm very happy with the Shorefly, but I do wonder whether the aircraft is just a little slower. A couple of times a year, I check the actual TAS by noting the ground speed by flying cardinal directions at 65% power at 7,000 feet. And obviously the average TAS that I get depends on rigging and how recently I've polished the airplane. But before the Shorefly, it averaged 153, 155 knots, which is pretty well book numbers. But now it's down about 149, 150. And my question is whether the variable ignition timing of the Shorefly would reduce the actual power output of the engine. Specifically, if I set 23-inch 2400 RPM, which would normally be 65% power on that engine, am I still actually getting 65% power?
And this comparison is before and after you install the Surefly, but not before you change the engine from the D engine to the A3B6.
No, sorry. Let me explain. 5 years ago, I changed to the 2 mag engine.
It's probably a
because
good
that
thing to do.
obviously opens the option of fitting a Shorefly. I couldn't do it with the previous one with the dual mag. But when I got, after about 3 or 4 years, I was up for my first magneto inspection, and I decided to change out the impulse mag for the Shorefly. And the comparison is before and after the fitting of the Shorefly.
Right.
Okay.
So, prior to the Shorefly, I was getting a solid 153, 155 knots, which for 65% power, that's exactly what the book says I should get. Now I get 149, 150. Now it's only a few knots, but people spend many thousands of dollars to get a few knots. And somehow it's lost, and I just don't know where it's gone. And I recognize, I've had the rigging checked, all the obvious sources. The tacho has been checked to make sure that I'm getting full RPM. And I'm coming really down to saying, well, could it be the Shorefly? I mean,
okay. Well, there are two things that come to mind here. One thing is the variable timing feature of the Surefly, which I don't think would be an issue here because I don't think it kicks in until the manifold pressure is well below 23 inches.
Correct.
If you were, if you wondered about that, it would be very easy to turn off the variable timing, which is just a dip switch setting on the Surefly, and see if it makes any difference. But I don't think it would, because I don't think the vacuum advance, if you want to call it that, it kicks in at a manifold pressure as high as 23 inches. What I think is more likely is that the Surefly was not properly timed to the engine. This is something we see a lot with the Surefly, because the timing procedure is totally different than it is for a normal magneto. The Surefly wants to be timed at 0 degrees, physically timed at 0 degrees before top dead center, right, where the piston is right at top dead center, and then the advance is set with the dip switches, not with physical rotation of the Surefly. And unless mechanics are really familiar with the Surefly, they often mess that up. So that would be my first suspicion is that the thing is not timed properly.
Interesting.
And you need to read the instructions very carefully and make sure that they're followed, because they're completely different than timing a normal magneto.
If you have an engine monitor, one way to kind of check would be to look at your EGTs during these tests before your SureFly install, and then look at them afterwards and see if they're higher. Because to follow on what Mike is talking about, the assumption would be that the SureFly would be firing later, so that it's not actually happening, it's not contributing to the combustion as it should. So you're basically flying around on one magneto, and that would cause your EGTs to go up
And your CHTs to go down.
and
It's like a
CHTs
mag-
go down. So
Like a
you're,
mag check. Yeah.
But
yeah, it's like doing an in-flight mag check.
I don't know when this installation happened, but you may or may not still have data from before the
Right.
thing went
Yeah,
in.
I definitely do have that data, but it is very interesting that you mentioned that, because I have noticed CHTs seem to be lower to the point where I
So
was getting quite
that confirms my suspicion that
Mhm.
that the thing was not properly timed, and we see that a lot with the SureFly, like I said, because the timing procedure is so radically different than what mechanics are accustomed to doing and have been trained to do. So I would revisit the timing and make sure
certainly will.
that the timing is done in exact accordance with the instructions in the SureFly manual. It is very different. There's nothing wrong with it. It's just different,
Yeah. Just different.
and it's not what mechanics are accustomed to.
And John, are you on Mooney Space at all? That's the online forum for Mooney
Yeah,
owners.
I do look at it occasionally, not frequently.
Me too, but I looked at it today.
Good.
I actually
There you
did
go.
a search asking about this, and there's a long discussion about performance with a SureFly on this engine. And people reported that they maybe got a few more knots when they were lean of peak at higher altitudes, but basically their speeds are the same. And they also confirmed that the SureFly doesn't even kick in with the advanced timing until you get above, say, 8,000 feet. So if you're reporting...
it doesn't really go with altitude. It
No,
goes
it
with
goes with
manifold
manifold
pressure,
pressure.
but
they said that the
Yeah.
manifold pressure you'd get at 8,000 feet is
Yeah.
about where you'd see it to start to
and
kick in.
you should get a few more knots out of the SureFly up at altitude where the variable timing does kick in, but you shouldn't really see any difference in airspeed with the manifold pressure above where it kicks in,
Right, because it's not doing
then
anything.
it does have a little hotter spark and stuff, but it probably wouldn't that alone would not make a noticeable change in performance. It would make a noticeable change in how quickly the engine starts and stuff
Everybody
like that.
said it starts great, just
Yep.
like a car, is what they said.
terrific.
So,
But it's up at it's at lower manifold pressures, which would typically be at higher altitudes. But the key thing is it's at lower manifold pressures that you should see the speed advantage. But if you're seeing a speed disadvantage, then I it seems very likely that the mag is not that the electronic mag is not timed correctly. The SureFly is not timed correctly, and it is a pretty bizarre. No, there's nothing bizarre about it. It's just so
No.
different.
Yeah, you hook a little voltage onto a particular pin, and the light comes on. You rotate number one cylinder at the top dead center until the light goes out. It has a 1/2 degree window where the light is extinguished, and this little LED is actually on the magneto itself.
Oh.
And so when you get it where the light is extinguished, that's it. But the whole process is on the SureFly.
So no more
instructions.
flower pot on the
No,
spinner
well, not
and
on
all
the
that?
Right.
Lycoming. On a Continental, you still have to find top dead center.
Oh, okay.
And for a SureFly, you have to time it on cylinder number one. When I time magnetos on a Continental, I usually time on cylinder number 5 because it's close to the prop.
Oh,
You can time on any cylinder you want, but on the SureFly, you have to do it
on
on
number one.
cylinder number 1. And on the Lycoming, you've got that wonderful big flywheel that's marked, and No special tools required.
With nail polish.
With
Working
nail
with
polish. Oh,
polish.
nail polish. Oh,
Works
I
great.
didn't know about the nail polish.
I knew pink was going to come into this
It's
a little
discussion.
tip.
Getting in here somewhere.
Yeah, it can't be green nail polish. It's got to be.
I don't know.
a
green
nice
nail
shade
polish.
But yeah, I would definitely revisit the timing on the
Yeah.
Surefly.
Especially,
Yeah,
if
thank you.
your CHTs are a little bit lower
Yeah.
and EGTs are higher than they were before, that's a
Sounds like
nice
winner.
conversation.
Comparison.
Yeah,
Or- no?
and confirmation. That's the right word.
Confirmation.
Yes,
Confirmation. Yeah, that's a good place to start. It's an excellent
Thank you
question,
for that.
John.
Yeah, it is a
Yeah,
great
I
question.
have the annual coming up pretty soon, so we'll double and triple check all of that, and I'll let you know what results.
Awesome. Yeah.
Very
we'd like
cool.
Feedback.
Yeah, thanks for the call.
Well, that's a wrap on another podcast. We count on you, our listeners, to let us know what we got right and, more importantly, what we got wrong. We always appreciate hearing from you. Most importantly, keep sending us those tricky questions to see if you can stump Paul. You can send your questions and comments to podcasts@aopa.org.
I don't know if I'm going to say see you or not.
Yeah,
after
you,
that.
you ever notice that they never tell us what we got right, but they
Always tells what we got wrong.
I'm
We'll see
sorry,
y'all
this
later.
Isn't part of the script. Bye bye, everybody.
We'll see you.